Hi, this is Kevin Schindler, and welcome to a special episode of From the Archives. Today we're in the back of the machine shop at Lowell Observatory, and if you've been with Lowell Observatory very long, you know that our Clark telescope was renovated last year, and the team that renovated that was led by Ralph Nye. We call him Ralph Nye, the telescope guy, because he can fix, build, repair, as he says, telescopes to toilets, or maybe it's toilets to telescopes. One of those things. So Ralph can build anything. And we also have Peter Rosenthal with us, who, like Ralph, can build anything. What better people than to have amateur astronomers who know telescopes better than anybody else to fix these old telescopes. So this is where they did a lot of the Clark renovation of the big 24-inch diameter telescope. And now they're working on the Pluto Telescope Renovation, a project which is going to last pretty much most of this year. And it includes not only work on the telescope and mount itself, but the dome that houses it. Today we're going to focus on the telescope. We're inside the machine shop of the observatory, and right next to me here is part of the tube of the telescope and the mount that it sits on. So let me introduce Ralph and Peter. Ralph, first, tell us a little bit about the tube and the mount there.
These are the main parts that we took out of the dome a few weeks ago, and they're sitting in here because we've taken apart pieces of them. Right here is where the back of the telescope had the plate holder, and the other side is where the lens assembly was. And what we're doing is piece by piece taking apart each part, and Peter's been working on a lot of the parts that are brass to start with, the little parts. The main big parts here need to be processed by sandblasting, and we're deciding whether to powder coat them or to paint them, and we're still deciding on the exact color to paint them, because nobody seems to know what the original color was, and we want to make it look very nice, and people would really appreciate seeing something totally restored and beautiful with all the brass shining. Yep. And just like the 24-inch Clark telescope.
And wasn't it that you found silver paint underneath the red?
Yeah, Peter, when he was taking off the plate holder and some of the other parts, there's several layers of paint, and there's some silver paint under the plate holder, and also some other parts had remnants of silver paint. So we're trying to decide the exact color when it was originally built.
And what's this tube made of?
This tube is made out of rolled steel, and there's rivets similar to the Clark telescope, putting things together, and we're trying to preserve everything in original condition and make it stand out just like the Clark telescope.
Mm-hmm. Now we're going to go back in the other room in just a minute, but anybody who's visited Lowell Observatory remembers the Pluto telescope, and they might remember more than anything this boxing glove. So Ralph, you better talk about that a little bit and why that's sitting there.
Well, I used to take care of this telescope when it was out at Anderson Mesa, and when you're working around a telescope and moving it around, there's a large counterweight that stuck out that would always, you'd hit your head on there and put a dent in your head, and so one year I decided to go to Plate Against Sports and buy 2 boxing gloves and put on the end just for a joke, but that seems to have been on there for 10 or 15 years, and it's become a kind of a part of the telescope. And I don't know if we'll be putting that back on or not, but it sure saves your head. Yep. And lets you know what to stay around and not be around.
And can you talk about the counterweights down here?
The counterweights are assortment of various cast iron weights that are about 50 pounds apiece, and there's odd-shaped ones that counterbalance other parts of the telescope that are not around the tube, and all of these will have to be sandblasted and probably powder coated or just regularly painted. There's quite a variety of them.
And again, this is a special live Facebook chat
I almost hit my head on that.
with Ralph Nye and Peter Rosenthal, and we invite everybody who's watching to send in questions. Ralph and Peter can talk about the work. How has this project been so far compared to the Clark renovation?
It's actually a lot easier because there's less parts, but the main problem with this project is the deterioration of the dome and the original wood that the dome was made of. So we have Glenn Hill, who is our wood craftsman that's making windows, and pretty soon we'll get into the dome itself. And we've already set up scaffolding inside the dome so we can take the shutters off and rebuild them. And there's a lot of woodwork to do and less telescope work on this project.
So the telescope came out in the winter, and you've been able to work on the telescope tube and the other parts. Glenn, now that the weather's good, he's really able to start getting going on that.
Yeah, that's right, because we're always fighting the weather, or we have other projects at the observatory too that we have to attend to. So,
The toilets.
Yeah.
Yeah.
Yeah. It's always,
We also don't have to deal with 5.5-ton chunks of telescope,
yeah.
which makes everything much easier. Since it's so much
It's a lot
lighter, we can just
smaller.
put it on a cart and move it around rather than having to hire a crane.
Yeah, yep.
Which is very tedious and expensive.
Well, let's go back in through the machine shop, and we'll go to where Peter's been working on some parts. And this is kind of a fun part of the machine shop. Peter, maybe just point out a couple things that we're seeing here.
These are parts that they've taken off the telescope. They either have to do with aiming the telescope or moving the telescope slowly. And these are just all auxiliary parts. Everything's coming off. Everything gets stripped of paint. This is just bare cast iron that's been through the sandblaster. And it all gets repainted and refinished, so it will look at least as good as new, because
Yeah.
we seem to care more about how it looks than they did originally. They were trying to get it done.
Now, with the Clark telescope, there are a lot of parts you took off that were left over from old research, and you never put it back on. Is there anything on the Pluto that's not going to go back on?
I don't think so. It was it's a pretty stripped down thing to begin with. So we're going to be putting everything back. All the wiring over here has been checked. These are just basically red lights in nice little brass holders that illuminate the pointers, so that when you aim the telescope at a given part of the sky, the coordinates show up nicely. So that's all been tested with new bulbs, so that'll work really nicely. All the rust has been removed. These long control rods, and you wouldn't think about it, but there's a lot of rust on this, and it all had to go away. So it's gone. So we're just waiting to get the word on the color, and then we can take this down and have it painted, or have Glenn paint it. There haven't been any fistfights about the color, but it's been close.
So you guys are both telescope experts. What do you think about this telescope, the way it was built, and how it functioned?
I think just like the Clark, we were always surprised with how good machine work they did. We tend to think of ourselves as being smarter and better than people in the past, but it's just not so. They didn't have certain capabilities with metallurgy that we have now, but they seem to care very much about the job they did. And when something is machined, it was machined really, really well. It's shocking still. So, and parts that don't need to be machined well, they're pretty rough. You can see parts like this here. They just needed to put this together. It doesn't have a critical function. Certain parts of it are, but the rest of it, you can see the welds are a little crude, but they didn't need to be fancy.
And what is that part?
This is the right ascension slow motion declination, slow motion arm. I'm sorry, right ascension slow motion arm. So that at the guide scope, you can turn a knob, a little wooden knob, and it actually moves the telescope against this, so you can aim it precisely where you need it to go. And there are two of these. One is for the north-south part of the sky, and the other is for the east-west part of the sky. We'll just destroy it all right here.
Live.
Live, that's right. You see it first.
Let's take a look at your workbench over there
Sure.
and see what you've been doing over there.
This is the 7-inch guide scope. It has a lens that was made in England by Troughton and Sims in the mid-1800s. It's actually, the lens itself is older than the Clark was in the late 1800s. And you can tell it's crudely made, but where it needs to be accurate, it's very finely made. And we're rebuilding the back end, which is where the astronomer would put his eye to guide the scope on a guide star, and the front end is the lens cell. We haven't played with that too much yet.
So this telescope, we keep comparing it to the Clark, and when we talk about that, we're talking about the 24-inch diameter in the big dome. The Clark was built by Alvin Clark and Sons in Massachusetts, and then the mount was built by Warner and Swayze in Cleveland. For this telescope, a lot smaller, Alvin Clark and Sons company still built it, but the mount was built in-house, is that right?
Yes, it was.
And so is it obvious when you look at it?
Well, they didn't have much money to work with, so they were trying to do it as cheaply as possible and with what they had here. So that's why it's a little bit crude, but it discovered Pluto. So
Did what it needed to do.
yeah, exactly.
It has a very singular purpose. All it needs
Yeah.
to do is track the sky accurately, and it does that very well. And that was the most important thing to them.
Sure. So what do you have in front of you there?
This is one of the old plate holders. I assume this is magnesium, is that right?
Yes, it is.
Yeah, it's magnesium. And this is where the glass plates would be installed. And because of the design of the lens, the film plane is not actually flat. It's got a curve to it. So they had to get this out. They would put a piece of glass in here, and you can see these little brass points. And by putting this on here and cranking it down, it would actually put a curve to the glass so that it corresponds to the focal plane of the lens that was made. And it's a pretty fancy, sophisticated item, because without this curve in the glass plate, we would basically get fuzzy images on a good portion of the plate.
And we'd just like to quickly recap. We're here in the Machine Shop at Lowell Observatory, and we'd like to welcome our Science Channel visitors. We're with Peter Rosenthal and Ralph Nye, who are heading up the renovation of the Pluto Telescope. And that's our local nickname for the telescope used to discover Pluto here at Lowell Observatory in 1930. And if you have any questions about the Pluto renovation, now's a great time to send those questions along. And right now we're with Peter and Ralph, and Peter's showing us one of the instruments, the plate holder that Clyde Tombaugh used in making the discovery of Pluto.
This is it's basically just a very large camera. We call it a telescope, but it's mostly a camera because you can't actually look through it. All you can really do is photograph through it. And so they would put a light-sensitive glass plate in here, and then they would put the dark slide in. And then it was after the telescope was aimed, they would take the dark slide out and make their exposure of. How long were these exposures? Do you know?
Usually 45 minutes.
45 minutes.
But so the telescope wouldn't shake when they took the plate holder out. They would take the plate holder out, and then at the end of the tube there's a shutter that would open up and allow the light to go into the telescope, and that would make it so that the telescope wouldn't shake. And then when the 45 minutes was up, they'd close the shutter and then put the dark slide back in and put a new plate in and take another exposure.
Yep. Process the glass. Glass plates aren't really available for this anymore. They're 14 by 17. I don't know if we mentioned that. They would be hundreds of dollars now if they were being manufactured.
The first plate holders were wooden, and then we started making aluminum plate holders, but they were still too heavy, so we made these out of magnesium. And when you machine magnesium in the machine shop, you've got to be very careful, because if the chips get too hot, that would cause a fire, and a fire that you couldn't really put out very easily. So, but anyway, the plate holders are as light as they can be and still do the job.
So we had a question from one of the viewers. What's the goal of doing this renovation?
Well, there's two historic telescopes here at Lowell Observatory. One is a 24-inch Clark telescope and the telescope that discovered Pluto. So they should be in top-notch condition, and they're on a tour every day, so they should be very presentable and be restored, so they'll last another 100 years.
Yes, we don't necessarily want it to look new. We want it to look like it hasn't been abused and it hasn't been neglected. And there have been times in its history that it's been neglected, and we're trying to erase that.
Peter, you mentioned that the telescope was designed for a very specific purpose, and that was to search the sky.
Yes.
But it was used for other things also. You might want to talk about that a little bit?
Perhaps
Or I
Ralph
can.
will answer that.
Well, stars move around in our galaxy, and that's called proper motions of stars. And after Pluto was discovered, we got a grant to study proper motions of stars, and that went on for many years. And Henry Gickless was the head of that astronomer who's been here for a very long time. And so they would take photographic plates and measure the star positions and see how they move around in our galaxy. And that was carried on for many, many years until the grant was dissolved. And so right now there's really no use for the Pluto telescope, but we would like to actually put it into operation so we could use it again and take more photographs to it, and possibly use the photographs to make copies and sell in a bookstore, and keep using the telescope. As long as you start using the telescope, it's always kept in a better condition because it's being used rather than just sitting there.
And this renovation is really an important part of our mission, because the mission of Lowell Observatory is to carry out astronomical research and share the results with the public. And we've been doing this so long that we have this great history. And in order to continue sharing, the discovery of Pluto, we have to make sure to preserve this stuff. And so, how long do you think this project's going to take to do all this?
Probably, because of all the woodworking and the dome work, probably at least a year. And the telescope will get done fairly fast, but we're not quite sure what we're going to get into on the wood until we start doing it.
Now, Peter was talking about the plates there. Talk about those a little bit, and are they still available today? Or
They are not available.
So if we're going to use this again, what would you use?
Well, we'd have to use film. We can actually find glass plates, but we can't find 14 by 17 glass plates that are actually we're able to use with any degree of reasonable expense. I found a company that makes glass plates, but 11 by 14 cost $140, and with testing and all that, it would be a very expensive process. So we'll probably end up using film, and we'd have to have a modified film holder to hold that. But the focal plane has to be accurate, so it works as it should. The lens itself is a blue sense. It was designed to transmit blue light, and so color pictures might not work so well because it would create some fringes in the photographs, color fringes that might not be too attractive. But it would make black and white photographs perfectly. But since color film is so popular, we'd certainly give it a shot.
Now, the last time this was used was when Hale-Bopp came by, the comet Hale-Bopp, and Henry Gickless was around, and he wanted to use this telescope to take one photograph a night, and the large format film was not available, so he purchased some X-ray film from the local hospital and took one photograph of Hale-Bopp every night, and went to the dark room and developed that. Each night he'd do that, and he has a whole series of plates that he took of Hale-Bopp, and it turned out very well. I modified a insert that went into the original plate holder, and he took 8x10 photographs of Hale-Bopp, and it worked out very well. So,
And we've got a bunch of new viewers coming on, and so maybe you could recap a little bit about the work, just both the dome and the telescope, because contrary to the 24-inch, which was very broken in a way with the wheel worn down, this telescope isn't necessarily broken, but it certainly needs work, and the dome. Maybe just kind of recap that.
well, the telescope was home built, and not only are we trying to make it look better, but we go through each part, and Peter goes through each part and see what he can improve on, and along with shining all the brass up. Every piece of brass is a piece of jewelry, and it should be stand out. And some of the really nice metal that's used are clear coated, and anyway, the telescope. You can only do so much to it because it's an antique, but we're trying to make it a lot better. The dome has been leaking on the shutters. It has original wooden shutters made in 1929, and the poor weather conditions in Flagstaff, from freezing and being hot in the summer and a lot of rain and wind, have taken their toll on the dome itself. So we're having to do a lot of woodwork on the shutters and replacing the top ones and maybe the side ones. And then the dome structure is a tapered rock building, and it absorbs water and kicks off the plaster inside of the dome. So we have to seal that, and the windows in the rock building are dry rotted. So we're actually making new windows and window frames out of oak, which will last a lot longer, and so there's a lot of more dome work in there than telescope work, and it's a smaller telescope than the Clark too. So,
And one of the things you're doing, Ralph, is as you and Peter and the rest of the team work on this, is to document everything, and
Yeah.
you're making drawings. Can you show us some of those?
yeah, sure.
We'll go in another room here at the machine shop.
Well, one of the first things we did was to take the lens cell out, and the telescope has it's called a Cook lens assembly. There's three lenses here, and in this drawing I made, it shows you kind of the outer part of the lens cell, and inside are full scale of the front lens, the center lens, excuse me, this is the sky lens, the front lens, the center lens, and the back lens here. You can see the shapes of them. And one thing is very interesting, the center lens is a very thin lens in the center. There's only about 82 thousandths thick in the center. And it's a very interesting lens cell design, and one which we've really never taken apart. Henry Giffords might have taken it apart when he used it, but there's no drawings of it because old-time telescope manufacturers didn't really share their drawing design from one to the other because they were in competition with other telescope manufacturers. So we never really had drawings of what it looks like inside. So this kind of shows you the outside of the cell and also what's inside of the cell here with this type of drawing. Peter took this cell apart completely, and over here is the result of some of Peter's work. It's a beautiful, very heavy lens cell to hold these three optical components.
How much does that weigh to hold?
It's a little over 100 pounds without the glass.
And here's kind of what it looked like when we took it out of the telescope. The lens was very filthy. The outside was in poor condition, and so by taking it all apart and painting it and making everything work well, then we have a nice restored lens cell assembly. Another thing we did is when we took the lenses apart, they were contained in little lens cells over here. Each one of those had a lens in there. And we took the lenses out and cleaned them, And similar to the Clark telescope, we measured the radius of curvature. This is a computerized drawing, full scale of what the lenses look like. And so we measured the radius of curvatures and can accurately draw the lenses as they are. So this is important information that we need to know that we never had before. And by making this type of a drawing, we can put this optical configuration in our ZMAX computerized optical program and see what kind of a design that we have and see if we can improve on it in some way. So it takes a little bit of work to do this, and taking apart the lenses carefully and cleaning each side and measuring with a spirometer and then calculating the radius of curvature and getting the accurate dimensions of the parts. So.
And just to recap, we're in the machine shop at Lowell Observatory, and Ralph Nye was just talking with us. Ralph is the instrument specialist here at Lowell Observatory, the director of technical services, and he builds and rebuilds telescopes from our oldest ones like the Clark 24-inch to the Discovery Channel telescope, which is Lowell's largest telescope today, a 4.3 meter diameter. Also with us is Peter Rosenthal, our archival restoration specialist, who is a watchmaker or watch repairman in history. Camera repairman. And so he's, between he and Ralph and the rest of the team, they're experts on fixing and replacing old pieces and parts of not just the telescope, but the dome itself. And Peter, you have a few pieces here that
Yes.
look like they're brand new, or maybe they're better than brand new. Maybe talk about those a little bit.
This was where the astronomer would put his eye and use the light that came from the guide scope, and inside it was a little crosshairs that was adjustable and had a little threaded wheel that they could turn and move the crosshairs and align to certain guide stars. It had a little filter wheel that they could filter the light for easier viewing. And this was all made with cast and machined brass and bronze. And this is a worm that actually is used with one of the slow motions to move the telescope. You would turn say this wooden wheel on a shaft. You can see it's knurled. It's made out of Honduran mahogany. We just rebuilt this and refinished it. And it would turn this gear and make this little bronze pin move side to side, which would actually move the telescope so you could aim it more accurately. So this has all got rebuilt, and it'll look very much like it does right now. It'll have a clear coat on it so it will no longer corrode and rust. And right here is an important part of the telescope, and this is what actually causes it to track the stars across the sky. This would rotate so that the large worm wheel, which rides on this threaded worm, would turn one revolution every 24 hours with the stars. And I just got done with this, stripping the paint, repainting it, and refinishing it and greasing it, and it works really well. We're quite happy with it.
Now, Ralph, maybe this is going to be putting you on the spot a little bit, but you've worked on the Clark 24-inch, which is more advanced than this telescope, right? This is kind of basic. You've worked on this telescope, and you've worked on the Discovery Channel telescope. And Peter was talking about fixing and repairing every single piece and part. Do you have a ballpark of how many parts there are on this telescope versus the Clark versus the DCT, just in real rough numbers, to show kind of how far we've come in telescope design?
There's probably 10 or 15 times more parts on the Clark telescope than on here, and similarly on the Discovery Channel telescope. Here's an example of the instrument package here. Just on the package that goes onto the back of the telescope is 744 parts. There's 1,400 screws holding that thing together. That's just one piece of an equipment that goes on the back of the Discovery Channel telescope. So there's thousands of parts on the Discovery Channel telescope they're all important to make that thing work, plus all the electronics. So
We've come a long way.
come a long ways, yeah.
What's been your favorite project to work on here? Do you have one?
Actually, the 24-inch Clark is probably my favorite. And next is the 42-inch telescope that we put a lightweight mirror in, and then we have an asteroid chasing telescope that is pretty close to my heart too. So there's quite a few telescopes here, yeah.
Well, we're winding down on time here, but maybe you guys could tell us a little bit about what's next to be fixed.
We're getting rapidly into both the woodwork on the Pluto Telescope. There's a lot of things have to be made and taken out and replaced, and the next big step is to finally decide on the color and work on the larger parts, which should be pretty basic because it's basically re-sandblasting and either painting or coating with similar to what we did at the Clark telescope, and that's really not that much of a big deal. But what Peter's been doing for the last couple of months is the real small parts that are brass, and they're very important, and that's what shows off the telescope. So we're getting that pretty well underway, and also the optics, and now we're working on the bigger, bulky parts. That,
I should say, if we'd actually had a decision made on the paint color, we would have been much farther along by now. All the parts that you saw on the table that were stripped of paint, they would be painted. But basically, it's just a matter of taking them down and bringing them back, and that only takes about a week.
So then the big work ahead is really the dome,
yeah,
and
it
Glen
sure is.
Hill is just starting on that.
Yes.
So next time we visit with you guys, we'll go into the dome and see what the
Okay.
progress is there.
Yeah.
That'd be great.
But the main thing is to, when the next time people come in and look at the Pluto telescope, we want to really impress them by how good it looks and how well it's maintained, and hopefully we'll be getting pictures of it and see how well the optics work. So,
Well, thanks for your dedication, Ralph Nye and Peter Rosenthal. Next time when we do a flag live, next time we do a live chat, we're going to go up to the Pluto Telescope Dome, and we'll see the work that Glen Hill is doing, repairing the walls and the ceiling and other parts of the dome. Thanks for joining us.